class. I'm back with your second day of notes about solving rational expressions. I'm going to start by just reviewing what I talked about in the first video this week, which was solving rational equations using cross products. So for the warm-up problem, it says to use cross products to solve for x. And so what we're going to do here, the first thing I want you to notice is that you have what's called a proportion. We have a single fraction equal to another fraction. And so to solve for x, all we have to do is set these diagonals, the product of the diagonals, equal to each other. So 3 times 4x plus 5 is equal to 9 times x plus 1. And notice how I put the expressions in parentheses, because in order to solve, I have to distribute the 3 and distribute the 9. So on the left side, I get 12x plus 15 equals 9x plus 9. Okay, and now I have x's on both sides, so I'm going to subtract 9x from both sides. And I get 3x plus 15 equals 9. And then I'm going to subtract 15 from both sides. 3x equals negative 6. And then if I divide by 3, I get x equals negative 2. And before I highlight my answer, I'm just going to do a real quick check of the denominators. If I let x equal negative 2, we just have to make sure we don't get 0 in the denominator, and we don't. And so I'm going to go ahead and highlight my answer, x equals negative 2. Okay, so that's a review of the day 9 lesson, which was solving by cross multiplication. So today we're going to look at some more difficult problems. The problems we look at today are not going to be proportions. Instead, we're going to have addition or subtraction on one side of our rational equation. Okay, and you might think we have to find a common denominator and add the one side together, or subtract and then cross multiply. But instead, we're going to use a different approach in which we're actually going to clear out the fractions in the very first step. Okay, so when you have addition or subtraction as part of your rational equation, okay, the first step is to find the least common denominator of all three terms in the equation. And I'll review how to do that as we go through the problems. Once we find the common denominator, we're going to multiply each term by the LCD. And when we multiply, we're going to end up crossing out common factors that appear in the numerator and the denominator. And that is going to allow us to clear all the fractions. Okay, and once the fractions are cleared, then we can go ahead and solve for the missing variable. So the steps sound very confusing until we actually do a problem. Okay, so let's go ahead and try one. So solve each equation for x, check for extraneous solutions. That just means make sure whatever value you get does not cause the denominator to equal 0. So the first thing is to find the least common denominator. And to find the least common denominator, you're going to look for any terms that appear once or twice in the denominator. Okay, so in this case, we have a shared variable of 2, and then we have a single 2. So all you do, you need to include a 2 in the least common denominator, and you need to include an x. So really just any factors that appear once or that appear more than once get multiplied to create that least common denominator. Okay, so we did step 1. Now step 2 is going to look a little tricky. We're going to multiply each term of the equation by the least common denominator. So I'm going to take each of these three terms, and I'm going to multiply each of them by 2x. So I have 2x times 4 over x, plus I'm going to multiply the second term by 2x. 2x times 3 over 2 equals, I'm going to multiply the third term by my LCD. So 2x times 10 over x. Okay, now remember when we multiply by 2x, you can think of it as 2x over 1. It's in the numerator. Okay, so if it helps, you can kind of put a 1 under and think of it as a fraction. Now, the reason we did that, here's where the magic happens. Now, we can cross out any factors that appear in the top and in the bottom. So, for the first set of fractions, we can cross out the x's. For the second pair of fractions, we can cross out the 2's. And then on the right side, we can cross out the x's. And so what we're left with, we're going to multiply. Now, we have 2 times 4 is 8. Plus x times 3 is 3x equals 2 times 10 is 20. And so by multiplying each term by the LCD, we clear the fractions. Okay, so to finish the problem, we're going to subtract 8 from both sides, and we get 3x equals 12. And then if we divide both sides by 3, we get x equals 4. So a little bit of a challenging topic to learn on your own kind of with e-learning. But if you kind of pause and try the problem again, or just stick with me for a few more examples, I think many of you can get the hang of it. All right, so the next one, we start by finding the LCD. Okay, so we have a single 5, so we need to include that in the LCD, and then we have a pair of x's. And so our LCD, we just multiply 5 times x. Okay, so once we find that LCD, we're going to multiply each term by 5x. So I'm going to do 5x times 4 over 5 minus 5x times 2 over x equals 5x times 6 over x. So I multiplied all 3 terms by 5x. And now is where the magic happens. So anything that appears on the top, you can think of this as 5x over 1. Anything that appears on the top and bottom gets canceled out. So the first pair of fractions, I cross out my 5's. I'm left with 4 times x. For my second pair of fractions, I have an x on top and an x on bottom. So I'm left with minus 5 times 2 is 10. Equals, for the third pair of fractions, I have an x on top and an x on the bottom. So I'm left with 5 times 6, which is 30. And so I cleared the fractions. So now if I add 10 to both sides, I get 4x equals 40. And then if I divide by 4, I get x equals 10. I do a quick check to make sure my denominator is not 0. It's not, and so my answer is x equals 10. Okay, so if you want to go ahead and pause the video and try the next problem, that would be great. And then just when you start it up again, you can follow along with me. Okay, so for this try problem, you should have gotten the LCD to be 3x. And then if we multiply each term by 3x, I know this is a little bit tedious, but if you kind of just follow the steps, all 3 terms, whoops, 3 over x, not 8 over x. I wrote that wrong. 3x times 8 over x. Okay, so once you multiply all the terms, then the 3's cancel out in the first pair, and you get 5x. I am sorry, I had a little typo there. That should be times. Okay, so for the second pair, the x's cancel out, and I get plus 9. And then for the third pair, the x's cancel out, and I get 24. All right, so now we subtract 9 from both sides. 5x equals 15. Divide by 5, and x equals 3. Okay, if I do a quick check, if x equals 3, I do not have 0 on the bottom. Okay, now sometimes when you're solving rational equations, you have an extra term in your equation that is a whole number. Okay, but you're still, if you have a rational equation that has addition or subtraction, you're still going to follow the steps I just taught you and multiply by the LCD. Okay, so when we have that extra term, it just looks a little different when we multiply by the LCD. So let me show you what I'm talking about. In this first problem, I want you to think of this as 12 over x plus 1 plus 3 over 1. Okay, so think of that denominator as 1. Okay, so when you find the LCD, you really just have to multiply 1 times x plus 1. Okay, there's a shared factor of x plus 1, and then you have a single factor of 1. Well, when you multiply 1 times x plus 1, you just get x plus 1. And so your LCD is x plus 1. So just like on the front, or on the first page, we're going to do the same thing to the second page. We're going to multiply each term by x plus 1. Okay, so I'm going to kind of highlight so you can see. I multiplied the first term by x plus 1. I have my equal sign. I multiplied the second term by x plus 1. And then I multiplied the third term by x plus 1. Okay, so now I can cross out. Think of this as x plus 1 over 1. Okay, so in the first set, I can cross out the x plus 1's, and I'm left with 4x plus 1. Equals. In my second pair, I cross out the x plus 1's, and I'm just left with 12. Now, in the third pair, I don't get to cross anything out, but all I'm left with is 3 times x plus 1. I didn't have a fraction to start with, so I don't have a fraction to clear. Okay, so now I am going to clean up my right side. 4x plus 1 equals 3x plus 15. And then I'm going to subtract 3x from both sides, and I'm going to subtract 1 from both sides, and I get x equals 14. Okay, and notice 14 plus 1 is 15, so I don't get 0 in the denominator, and so the answer is x equals 14. All right, let's try one more together. So this one, the least common denominator, again, if we think of this as 7 over 1, we need a 1 and we need an x minus 2. So 1 times x minus 2 is just x minus 2. So you're going to multiply each term by x minus 2. X minus 2 times 5x over x minus 2 equals, I'm going to take the 7 and multiply 7 times x minus 2, plus I'm going to multiply my last term by x minus 2. So x minus 2, oops, sorry, times 10 over x minus 2. Okay, so now I'm going to cancel out anything that appears on the top and bottom. I can think of this as x minus 2 over 1. And so I can cross out the x minus 2's here, and I get 5x equals, okay, nothing cancels here, but all I have to do is distribute my 7x minus 14. And then right here, I cross out my x minus 2's, and I just get plus 10. So 5x equals 7x minus 4. And then I'm going to subtract 7x from both sides to get negative 2x equals negative 4. And so x equals positive 2. But if you do your quick check, notice if x is 2, you get 2 minus 2, which is 0. And so this is called an extraneous solution. And we say that there are no solutions, okay, because your solution cannot cause division by 0. So it hasn't happened often in these notes today in the last set of notes, but just make sure you're kind of aware of when that can happen. All right, so go ahead and pause the video and try this last one. And when you're ready to join me, you should have an LCD of x plus 1. And if we multiply all of the terms by x plus 1, okay, we can clear the fractions. I'm going to multiply this up here. Okay, so you multiply each term by x plus 1, and then you can cross out the x plus 1's here to get 5x plus, nothing cancels here, we just distribute to get 4x plus 4. And then on the right side, the x plus 1's cancel, and we get 22. So now we have 9x plus 4 equals 22. Subtract 4, 9x is 18, divide by 9, and x equals 2. Okay, do a quick check. If x is 2, you don't have 0 on the bottom, so you can highlight your answer. All right, so thank you for tuning in, and go ahead and try the 4 problems in the day 10 practice. Have a great day.